In this video, we're going to look at the binomial expansion for C4. Now we've already met the binomial expansion when we studied C2, and we looked at expanding expressions such as 1 plus x to the power n, where n was a positive integer. And one of the formulas we saw was this one here, which is 1 plus nx plus n minus 1 over 2 factorial x squared plus n minus 1 n minus 2 over 3 factorial x cubed, etc. And because we're starting with the term x to the power 0, that gives us n plus 1 terms. Now in C4 we're going to extend that idea and we're going to ask ourselves, well, what if n is any rational number? And we'll try expanding this expression here, x plus 1 to the power 3 over 2, and we'll see what happens. Now I've written out my expansion and the expression I want to expand, and let's do that. So we've got 1 plus nx, which is 3 over 2x, and then plus n minus 1, which is 3 over 2 multiplied by 1 over 2 over 2 factorial, and that's x squared, and then plus 3 over 2 multiplied by 1 over 2, which is n minus 1, then n minus 2 gives me minus 1 over 2 all over 3 factorial, and then multiplied by x cubed. Now we can see there that as we go n minus 1, n minus 2, we've actually gone to minus a half. So that means we're never going to reach 0. So in fact, this expansion is going to be an infinite series. So if we just carry on now and simplify that, so we've got 1 plus 3 over 2x, and then plus 3 over 2 multiplied by 1 over 2 gives me 3 over 4, and then divide that by 2, that gives me 3 over 8 x squared, and then plus 3 over 2 multiplied by 1 over 2 multiplied by minus 1 over 2 gives me minus 3 over 8, but then divided by 6, which gives me 3 over 48 x cubed. And simplifying once again, that gives me 1 plus 3 over 2x plus 3 over 8 x squared, and then minus, if I simplify that fraction, I've got 1 over 16 x cubed. So going back, I've got my expression here, and we've said that that's actually going to be an infinite series. So what we might like to know is, if it's an infinite series, is it going to work for all values of x? So I've chosen some values of x here, and I'm going to substitute those values into the left-hand side and into the right-hand side and see if we get a good approximation. Now you might like to stop the video here and try those yourselves. So if you did that, this is what you should have found. So these are the values, which I've rounded to 6 significant figures where appropriate. These are the ones I got for the actual brackets here, x plus 1 to the power 3 over 2, and these were the values I got when I substituted into the expansion. Now some of those are quite close together, but some of them are not. So looking at the first 3, we seem to have a very good approximation here. They're very close. But if we look at the next 3, they're not so good. In fact, when we try x is minus 3, if we substitute that into the bracket here, we're actually taking a square root of a negative number, so we don't get a real value there. And so the expansion gives us 28.56 is meaningless. And looking at when x is 15, these two values are completely different. Again, I think we can safely say that the expansion there is meaningless. So, can you think of what values of x we can substitute which are going to give us a reasonable approximation? Now we'll also have a look at the graph. So I'm going to plot the bracket here, 1 plus x to the power n, and I'm going to plot the first 5 terms, in fact, of the expansion. And we're going to have a look at how close they are. So here's my graph, and I've got the blue curve is my expression, 1 plus x to the power n, and my red curve is the expansion of the first 5 terms. I'm going to have a look at what happens as I change the value of n, and we're going to think about where the two curves are quite close together. So if I change my step size to 0.5, so I've got n is 3 at the moment, and if I just increase my values of n, and we'll have a look what happens, and then I'll go down, and we can also have negative values for n as well. So if I stop there, when n is minus 1.5, you can see that around this area here, which looks to be approximately 0.5 and minus 0.5, we've got very close graphs here, so clearly good approximations. But beyond that, the two curves diverge, and just increasing that. Now there, and when we get to that point when x is minus a half, we can probably say we've got a fairly good approximation between 1 and minus 1 almost, and then just moving up. So it does vary, some are closer than others or give her a better region or a wider region where they're quite close together, but at this point here we can probably say between say approximately 1 and minus 1 seems to be giving us a good approximation. And then as we increase n, our region is getting a little bit smaller there, but probably somewhere between minus a half and a half gives us a very good approximation. So can you think of cases, or can you think of values of x rather, where we're getting a good approximation and not a good approximation? So what would you say would be the region within which x would give us a good approximation, or which the expansion is valid? So I'd like you to think about that for homework, and then in the next lesson we'll talk about for which values of x the expansion is valid and why. So let's have a look at a particular expansion here. So we'll do one together, and I'm going to have a look at expanding 1 minus 2x to the power a half, because the square root is the power a half. So let's use our formula. So it's 1 plus nx. So 1 plus, now n this time is a half, and x. And then I made a little error here, so I'm just going to go back because it's not x. In fact, it's minus 2x. So if I put that in, so n is a half, and I'm going to put in brackets minus 2x. And then the next term will be plus 1 over 2, which is n minus 1, which gives me minus 1 over 2, over 2 factorial, and then multiplied by minus 2x to the power 2. The next term will be plus n, which is a half. N minus 1 is minus a half. N minus 2 is minus 3 over 2, over 3 factorial, and that's minus 2x to the power 3. And then let's put dot, dot, dot. And then simplifying, so I always recommend write out the numbers substituted into the formula and then simplify. You'll get marks in the exam for doing that, and I think you're less likely to make an error with the calculations. So let's simplify now. So we've got 1, and this is going to be minus because it's minus 2 times a half, so minus x. And the next term, we've got a minus a half, but we've got a minus 2 squared, which gives us a positive value, so we're left with just the minus a half. So minus, and then a half multiplied by half is a quarter, divided by 2, so that's 1 over 8. But then we've also got to remember we're squaring the 2, so that'll be 4 and then x squared, and I'll simplify that later. So the next term, let's see if it's going to be positive or negative. I've got a minus 2 cubed, which is minus. I've got a minus a half and a minus 3 over 2, which together make positive. So all together there, we've got minus. And that'll be 3 over 2 times 2 times 2 is 8, divided by 6, which is 48. So I'll write that down. And then that's minus 2 cubed, which is, we've already taken into account the minus, so I'll leave that. So 2 cubed is 8, x cubed. And then finally, simplifying for the last time, so 1 minus x minus a half x squared minus 3 over 38 multiplied by 8 gives me 3 over 6, which is 1 over 2 x cubed. And that's our expansion. So now it's your turn to have a go. So I'd like you to do this task for homework. There are 2 questions here. So the first one, quite a simple one, of expanding 1 minus x to the power minus 2 in ascending powers of x. So that's from the 1 and then plus x squared plus x cubed terms. And the second question, slightly more tricky, 1 plus 3x to the power minus 2 over 3, again up to the x cubed term. I'd then like you to think about the values of x for which the expansion is valid. And we're going to talk about that in the lesson as well. And then part C, I'd like you to think about choosing a suitable value of x and find an approximation to this expression here. Now we did something similar to that in C2, and again we'll talk about this in the lesson.